All right, we're going to be tying some information together. So before we do that, we just want to do a quick little recall. To find the x-intercepts, you always set the numerator equal to 0. Remember, x-intercepts are the same as your zeros. And then to find the vertical asymptotes, or removable discontinuities, set the denominator equal to 0. Okay, so and remember, removable are your wholes. Removable. Those are your wholes. Okay, and when you guys do this, I would always recommend looking for your removable discontinuities first. Find this first. Find first. Okay, then look for your vertical asymptotes, because whatever cancels, that's your whole, and whatever is left in the denominator is your vertical asymptote. All right, so here's our example 3. We are given this function, find the following. So the way we find x-intercepts is you take your numerator and set it equal to 0. The reason this is to find x-intercepts, it's always when your y is equal to 0. So you would take it and you'd set it equal to 0. And when you multiply, you'd multiply both sides by the denominator. Those would cancel. And every time you'd be left with the numerator equal to 0. Okay, so in this case, it's x equals 0. B says find your vertical asymptotes, but remember I said find your removable first. So let's look if we have any removable. That would be if anything cancels or simplifies. There is nothing that cancels or simplifies in this case, so there is no or none for that. And then vertical asymptotes are when you take your denominator, set those equal to 0. So we have a vertical asymptote at x equals -5. Now horizontal asymptotes, that's when you do your leading term over your leading term. Okay, so we would have horizontal asymptote. My leading term in the numerator is x, the biggest degree. And in the denominator, it is also x. So we have x over x, which simplifies to 1. So y equals 1. That is our horizontal asymptote. Okay. The same thing is true when you look at your limits as you go to infinity. You want to do leading term over leading term. So it would just be your limit as x approaches infinity of x over x plus 5. And then you do your biggest degree over your biggest degree. X over x, which is 1. So this answer would be 1. And the same would be true going to negative infinity. You'd set it up the same. Instead of having positive infinity, you'd have negative infinity, which is 1. Now for G and H. The trick with this one is we know there's a vertical asymptote going on here, so I need to look at it graphically to figure out what's going on. So I'm going to graph this function on my calculator. So we're going to go to y equals, clear it out, and I'm going to graph it. Probably the easiest way to graph it is to go alpha f1, so you can get that n over d, and type it in. So we have x, and then it'd be x plus 5. Yes. And then let's hit graph. All right, so we said on here that we had a horizontal asymptote at 1. If I look, does it look like there's a horizontal asymptote at 1? I would say yes, so that's looking good. And then we are looking at our limit as x approaches -5 from the right. Okay, so if I go to my graph, here's -5, and it looks like there's a vertical asymptote there. And as I approach from the right, I'm following this curve. As I approach my asymptote from the right, it looks like I'm going to go down to negative infinity. So this answer would be negative infinity. And then as I approach -5 from the left, I would go ahead, pull my calculator up. Here is -5, and as I approach it from the left, we're going to continue to go up and up and up. So the answer would be infinity. So that is example 3.